Hello, I'm Justin Dykhouse. I've been working in Houdini for a couple of years now, and I found that it's kind of like a big workshop. It's like a big garage. There's lots of different corners of it, lots of different stuff you can do with it. So what I want to talk to you tonight about is something like one corner of it that I kind of set up a workshop and started working in. So we're going to be talking about Houdini. We're going to be talking about art, personal connection to art, that kind of stuff. But we'll do it really quickly, so the boring stuff will go by quickly, hopefully. I've been making some sketches and works on paper using Houdini, and I brought some sketchbooks, so after the talk, if you guys want to take a look through them, I'll leave them up here, and you can kind of see what I'm talking about. So, again, I have a background in, I'm Justin Dykhouse, I have a background in motion graphics and digital art in general. I'm currently a Houdini generalist at Magnopus downtown. And at Magnopus, we do a lot of visual effects, but also a lot of like game engine stuff. It's actually mostly game engine stuff. It's VR, AR, that kind of thing. And I've always been a fan of art combined with code combined with art, that kind of thing. And there's a lot of different examples of that. So we're going to talk about one today. So it's plotters. Plotters is sort of like it's like a robot that can draw pictures. It's kind of like a printer. But instead of printing out one pixel at a time, one dot, it moves a pen through space. If you put it on, or it moves an arm through space, you put a pen in that arm and you put some paper under it, it's going to draw you a picture. There's lots of different kinds. This technology's been around for a really long time, since I think the 50s or something like that. Over on the left-hand side, over here, you can see a couple of older versions. And then there's some more modern ones. This is a DIY, somebody built one. This is a control panel. I just put this in here because I think this is cool. If you like old tech, plotters are a really cool area to look at. There's a lot of cool like control panels and stuff like that. But then the two main ones that we're going to be looking at are these two over here. So this one on the bottom is called a Linus, L-I-N-E-U-S. And it's like it's a whole system that these guys in Britain made to sort of share drawings with the world. So like you get the little plotter and you put a little pen in its hand and then it has a light on it. And when somebody somewhere in the world drew a little picture, the light lights up and you can hit the button and it'll draw the picture for you. So then you get like a little drawing delivered to you that somebody drew. That's kind of like it's like a more sort of colloquial use of it. And the one on top is called an AxiDraw. And this is a very widely available, very good plotter to start with. It's not too much money, and it's kind of plug and play. It works right away. You don't have to spend a lot of time setting it up. So if you don't want to spend a lot of time coding or mucking around with that kind of stuff, you just plug and go. I mean, it was like 5 minutes from unboxing to first plot. It was very cool. So what do you need in order to make a plot, a drawing? So you have 4 steps that you have to go through. You have to create a file. That's like the fun, that's the more creative side of it. You have to convert it to what's called SVG, which stands for Scalable Vector Graphics. It's a file format. We'll talk a little bit more about that. You have to prepare it for the plotter, which sounds like a simple step, but it's actually not. Your plotter might not speak the same language. It might be a really large one. It might be a really small one. It might have a special kind of pen that you have to use with it, whatever. So you have to prepare it, and then you have to actually plot it. And that's more of a physical thing. That's not in the software. That's where you have to sort of like help it to create this drawing. There are ways that you can do. Basically, the two of those steps that I do with Houdini are the first two. I create a file and I convert it to SVG. That's what we're going to be talking about today. So I'm going to show you a HIP file and some Python, and I'll show you. But I know that there are people that do all the steps with Houdini, and they talk to the plotter using the code that they've written in Houdini, that kind of stuff. Maybe someday I'll do that too. I don't know. We'll see where it goes. But for right now, I'm just doing these two. That's what we're going to talk about. So let's talk about step 1. Step 1, create a file, make it, cool, make it weird, make it interesting. And even if it starts out super basic, it will be even better when you plot it. I guarantee it. So it will have a certain something that's when you sort of bring it out into the world. So let's look at a file. So on the left, I've got a geometry network, and on the right, I've got another geometry network that does the actual export. So right now, we're just looking at this HIP. Thank you. That's very handy. It's pretty straightforward, which is something that I think you'll find if you watch Houdini tutorials. People make the most complicated network you've ever seen, and then at the end they go, oh, "So pretty straightforward, pretty straightforward." So I won't say. Well, I already said it, so I can't. But this one I'll try to actually make it straightforward. So draw curve is a SOP that allows you to, if you hit enter, you'll get a little guy, and you can actually like draw lines. Draw curve draws those lines onto a plane projected in space. We're going to take those lines, we're going to hit them with a resample. A resample is a very simple node that basically goes through a line and adds new points. It recomputes basically the line. So if you'll see, my draw curve is kind of like, you'll notice there's points all over the place. Oh God, that was not supposed to happen. There's points all over the place here. There's more over here than there are here. It's just kind of ugly. If we run it through a resample, now they're nice and spaced out. And the important thing about a resample node is that you get a couple of little attributes for free if you use it. So you get curve U and you get tangent U. These are both really useful. Curve U is basically just the measurement of how far along the line you are, starting from 0 and going to 1. You can find that useful in all kinds of situations. But I'm going to use tangent U instead. And tangent U is basically a vector, so it's 3 floats, that just says which direction to the next point, more or less. Basically says, I'm here, here's where you need to go to the next point. More or less. That's essentially what it is. That's what we're going to use it for today. Next, I have a point wrangle with some vex in it. Don't be afraid, this is the only vex you're going to see that is part of this part of this presentation. It's basically just creating a float called V, which, as you may know, is velocity, and assigning it it's creating a vector called velocity. It's assigning it what we got from tangent U, and then multiplying it by a slider, which I put down here. So if we move it up, it's more velocity. Move it down, it's less velocity. Now, parallel to that, over here, I've got a grid, and the grid is also kind of hanging out in space here, just pretty straightforward. And the number of points in the grid, that is the number of rows and columns, are very important. So we're going to leave that at 20 for now, but we may change that later. So I'm going to take the grid, and I'm going to take the line that I made and prepared and put the velocity onto, and I'm going to put them together in an attribute transfer. Attribute transfer is going to take the velocity from the line that I drew, and it's going to take that attribute and it's going to transfer it onto the points in the grid. So now, if I look at this grid and I turn on point velocity, excuse me, if I turn on, where is this, V, you'll notice that there are a couple of yellow lines. Now this is indicating that there's velocity on these points. And you may also notice that this is where the lines were that I drew. So if I draw another one in here, actually if I go in here, draw another one, just put a swirl right in the middle there, and now I go back to attribute transfer. Now there's a line right in the middle with velocity on it. So we've transferred the velocity to the grid, and now we're going to do something called attribute blur. We're going to take those values that we had here, and we're going to blur them. That means kind of spread them out, soften them a little bit. If I zoom in here, now you'll see more points have the yellow line, and that indicates that they have that attribute. Back up here, there's fewer of them, and it's longer, so it's a higher velocity. Down here, it's more, and it's less velocity. And then down here, we're going to say a VDB from polygons, which is a very useful SOP. Use this all the time, VDB from polygons. It doesn't look that great in this case, because all it's doing is it's creating a line of voxels, 1 voxel thick by however many it is long and however many it is tall. But what I've done here is I've said, okay, take point V, this attribute, and turn it into a grid within the VDB that's velocity. So we're going to need that. So now if I middle click on this, you'll see we've got both surface, which is something created when you drop down this node, and we've got velocity. Doesn't look like much, not that amazing. But if we take the grid and we scatter some points on it, scatter SOP also very useful. Basically just throws a bunch of points onto whatever surface you give it. And there's some more fine tuning you can do. You can say more over here, less over here. You can say don't spread yourself out so much, just actually be truly random. But if we give these points and this velocity VDB to a volume trail stop, something magical happens. It takes the velocity from this VDB, and it takes these points, and it makes trails come off the point, and makes them follow the VDB, the velocity grid of the VDB. So here in the volume trail, I'm going to move, where is it? Trail length. I'm going to move trail length down. And you'll see here are the actual points. If we look at the scatter and we look at this, same kind of thing. The magic happens when you make the trail length a little bit longer. So, let's see. This is all because of the attribute blur. Remember when I said that it softens and it spreads out the velocity volumes? If I turn this down, turn the blurring iterations down, it's going to start looking more and more like the sort of the original lines that we drew. So you've got to turn this up. And the fun part is, if I look at this, but I go back here and I draw, actually I go back here and I'll clear. Actually drawing a line and watching it kind of develop as I pull it. So it's kind of fun. I can go, you know what I want up here is I want a little thing that comes around like that. Let me turn the, let's see, kernel radius is fine. Threshold also is another fun one. You'll notice that I'm adjusting parameters on a couple of these, and the ones that I do have green on them. That's just a little color code I use to tell myself these nodes contain what may be useful attributes. I want to mark them so that later I want to come back. Also, if I'm doing anything at all, I usually comment this stuff just because I forget. So you just go in here and hit the I, and then you can write your own little comment in here, check this button, and it'll just show up in the network. I find that really handy. That looks kind of cool. Let's leave that. So now we have used Houdini to create some lines on a grid in a square. And that's all we're going to need for this step. So let's go back. Let's look at step 2. We're going to need to take these lines, we're going to need to convert them into an SVG. It's a really interesting file format. It's something that we're going to use to translate the internal Houdini data structures like polylines and squares and points and that kind of thing into something that's read by a general purpose file format. And the file format, the SVG, is going to be really easy to open. It can actually be opened in a browser, which is kind of cool. And let's see. Python is something that is a language that's really good for doing this kind of thing. Basically taking the internal Houdini data structures, turning them into a line or a point or a dot or something in an SVG. So we're going to use a Python SOP. Don't get scared away. It's a few lines of code, but I promise I didn't write it. I got it from Intagma, so they showed me how to do it, so blame them. So let's take a look at that. So if we go back into the HIP file, and we go, that's the wrong session. If we go back up, we were just in here in line field. Now let's go over here to export to SVG. This is a special thing. I did a month of dailies, like daily plots a while back, and I sort of just built this file up over the course of the month. And so at the end of the month, I had this, my tool that I had built. It's made to take in a variety of different kinds of geometry and turn it into something that I can plot. So I can take 3D geometry and plot it if I want. It's a little bit more complicated. I'm not going to touch on it tonight in the talk, but I'd be happy to talk about it if you guys want to afterwards. The important thing is right now it's going to take these lines over here and transform them into an SVG, really simply. This is all more stuff to do with the 3D conversion. So here is the Python SOP, and it's got some Python code in it over here. And again, this is just copied and pasted from Intagma. I'm not a coder. Essentially, it's going to go through, pull each one of these little components and turn them into, append them in a file, an SVG file. And at the end of it, there's a couple fields that I put in here for myself. So like file name, what I want the output to be called, which version this is, because they do several different plots, and some of them look cool and some of them don't, but you can't go back if you change one. I mean, you can, but it's not worth it. So just write out a version, call it version, C or whatever. I have some variables in here. So like $output, that's a custom folder that I always define, which is wherever I want my output to go. It's somewhere in my job folder, so that I don't have to remember, oh, it's on the D drive and then my folder. I always just know where it is. Handy little thing, if you have an expression like this where you're using this kind of stuff, if you middle mouse click on it, it'll show you what it evaluates to. So this is where this stuff is going now. So on my D drive at home, in my VFX folder, in dailies, blah, blah, blah. So it's kind of handy. So I have worked with Python a little bit, but I'm not sure how to be super elegant about it. So all I do is I connect this up, and then I switch off of the thing, and I switch back on, and then I click in here, and I say some magic words, and then eventually it writes out a file. A file appears somewhere in a directory where I've told it to appear. I'm going to show you what that looks like. So here's what I did actually on Christmas last year, and it just shows up. And as I mentioned, SVG is a really easy file format for different programs to read. You can open it in a browser if you want, and I see that on this computer, SVGs are already associated with a browser, so I'll just double click this. And it'll open up Google Chrome. So here's the plot. So like this was one that I did, and I said, okay, put a square around it and with this stuff. But the fun part is just reading the vector data and rendering it out in the web page. So it's useful to preview. So we've converted it to an SVG. That's step 2. On the left is an example of the Python code. Now on the right, what you're looking at here is that's what the SVG file format looks like. It's just a list. It says path, and then it's got a bunch of coordinates. And what the plotter will do is it'll put the pen down where it starts, and it'll move the pen around until it stops, and then it'll pick the pen up again, and it'll go to the next one and do that. Same thing all over again. So let's move to step 3 in order so that it can actually do that, so it can move the pen along the line. So different plotters have different needs, like all of us. Some of the ones I showed you in the beginning, the big industrial plotters, they speak a different language. There are some that are made by Hewlett-Packard back in the day, and they have their own language called HPGL, and you can learn to program in that, and then you can write your own generative programs for HPGL. Some of them are very small. Some of them have limits in the different kind of pens you can do, so they have different needs, so you have to prepare this artwork for your plotter. You have to do some optimization. Well, you don't have to, but you can. I guess that's the definition of optimization. One of the things is that that list of points that I showed you at the beginning, that I showed you just a few moments ago, where it'll put the pen down and move the pen along and pick it back up again. The next one may be somewhere random on the paper. So in that case, you're going to draw a line, and then your pen's going to go all the way down here, and then draw another line. And then it might go all the way back up to the top left corner and draw a line up there. So you want to have the best path. You want to put the pen down, draw a line, pick it up, put it down somewhere relatively close, draw it some more. Another thing that you've got to do with optimization is the speed versus the accuracy. You can have your plotter move really, really fast, and you can get your plot done very fast, but maybe the mechanics of it can't handle that speed, and your plot ends up looking a bit crappy. On the other hand, you can have it move very slowly and very accurately, but it takes 4 hours. Nobody wants to wait for the thing for 4 hours. You got to go. You got to have some dinner or something like that. So you want to find the right mix for you, speed versus accuracy. If you're doing dailies, you'll find probably it'll be a little faster, and you'll just be ready for, whatever happens. If you're making a piece of art that you intend to sell or present, then obviously you're going to take some more time with it and have it be a little bit slower and more accurate. You can have different color inks. You can split these lines up into different layers in the program that you use, which I'll cover in a little bit. And so that, it'll only draw a part of the drawing, and then it'll stop, and it'll wait for you to put a new pen in and tell it to start again, and then it'll start drawing in green or whatever. It's another thing that you might prepare it. It turns out that if you buy a plotter, you get really interested in different kinds of paper and pens. I did not know that, and so I found myself learning a lot about pens and paper. I'm not from an art background, and so I didn't know what Bristol was versus vellum versus sketch paper. I was just like, yeah, just some paper. Just give me some paper. Send me some paper. And And I learned that certain pens are good with certain papers, and, you know, they have different looks to them, that kind of thing. And finally, I mean, this is your art, this is your expression, this is what you're saying to the world, and we're changing it from something that's on the computer into a physical object. I haven't had that a lot before in my career, and so I find it, you know, I find it appropriate to spend time and care and attention making it right, you know, and there's a satisfaction that comes from that. The next thing is I'm going to show you guys Inkscape. I'm not going to do a whole demo. This is basically the long and short of it. Inkscape is an open source program that was written to kind of do a lot of the same stuff that Adobe Illustrator does. So if you're familiar with Adobe Illustrator, may God have mercy on your soul. I don't like Adobe Illustrator very much, but I do like Inkscape. It makes a lot of sense, and it does a lot of things right, and it's very simple, and it's free. So these are all good things. On the left in the red, we have the AxiDraw control. So when I was saying that you get this thing and then about 5 minutes after you take it out of the box, you make your first plot, it's because Inkscape is free and it comes with this stuff already installed, and it's ready to rip. Like, that thing is ready to go. You just open up the control panel and tell it, and it'll do it. So here's the control panel. There's a few different options for how you want your thing to go. So here's layers. So that's like what I was saying, like if you want to draw a certain layer, then have it stop, change the pen to another one. Comes with a couple options. So if you have solid shapes, you can tell it to hatch them, fill them, do a couple different kinds of things. Over here on the right in the blue is the layers menu. So if you break your file up into layers, either in Houdini or manually in Inkscape, this is where you line them up. And they're starting with numbers because you tell it, okay, only draw, right now I want you to only plot layers that start with 1. So it'll plot layer 1 and 11, but it won't plot layer 2, that kind of thing. It's really handy for organizing your file. Finally, in the middle, here's a plot. This is actually the SVG opened in Inkscape, and I'm prepping it and I'm getting it ready to go. So I went in here and I selected a couple of these lines, and I put them onto a new layer, and then I was like, okay, that's going to be green, so I'm going to do that, or that's going to be red. And this is all sort of part of the prep. It's part of the process. It's part of bringing these things out of yourself, you know. And then finally, there's the physical part of it. There's watching this machine work, but also helping it work. So you want to be there to ensure that the process is going well. I thought about bringing the plotter today. I really did, but I didn't end up doing it because I haven't had it a super long time. I don't know if it's going to be super finicky, but it goes on the table, takes up about this much space on your table, something like that. Anyway, the one I have does. So you've got it there, and you've got your paper there, and you've got your pens, and you're there to make sure that the process is going well. And that means that you've got to switch the pens out for the different layers. It means that sometimes you got to hold the paper down. There's probably more efficient ways of doing it than doing it with my hands, but again, I'm kind of new to this, so I actually hold the paper down. Feels like I'm, holding it steady. And frankly, it's just kind of a chill process. Like the part where you're plotting, where you're watching the machine work, you're kind of helping it do its thing. It feels good to watch what you've done, be produced, and it sounds kind of cool, and the motion is just kind of pleasant to observe. So I got a little. This isn't mine. This is somebody who gets it on YouTube. They just took a video of their plotter and they just recorded the audio, and that was it. They didn't say anything. They didn't play any music. They just we don't have audio on this, so you're not going to be able to hear it, unfortunately. This is the time where you get to watch what you've done. You get to reflect on it. And you get to see this thing's interpretation. You're sort of like collaborating with it, kind of. I mean, it sounds kind of cheesy, but that's honestly the way it feels. And you'll notice new things in your work that you didn't notice when you were putting it together, that when you were looking at it on the screen you didn't see. This is one that I think it's done all in one continuous line using something called a strange attractor, which is like a math thing, which is the technical term for that. And this is a larger plotter than I own, but it's the same brand name, so it's AxiDraw up here. So this will give you a good sense of kind of what it is. It has kind of a sing-song quality to it when it's moving. It's kind of but it's very digital. It sounds like sort of like heavily compressed MP3s or something, because the stepper motors are just like super, I don't know, it's wild. Lots of different pens and paper combinations, like I mentioned earlier, will give you different results. And sometimes you won't like it, and sometimes you'll be surprised how much you do like it. So I would say, if you have any interest in any of the things I've discussed, or if you have any interest in this sort of thing, there's a lot out there. There's a lot of resources on the web. There's people in this room, in this very room, who have done this kind of thing before, and who would love to talk to you about it. I'm really happy that I found this little corner of the Houdini workshop, that I found this art form, and I said, you know what? People use a lot of different kinds of programs to make these things. I already have a program that I know a little bit that I can use to create something interesting. And so the final thing that I will leave you with is there's a couple of examples up here. If you're interested in seeing more of these, a really good place to start is with the hashtag plotter Twitter. If you go on Twitter, if you go on Instagram, these are great. Just plotter Twitter. For some reason it's plotter Twitter, even on Instagram. I don't know why. But you'll see a lot of this kind of stuff. And for me, that just kind of draws me in, so to speak. I didn't do that on purpose. And just quickly to finish up, so different plotters that you'll run into when you first start researching this stuff are Axidraw and Linus, and then there are some from Roland, which is, they also make synthesize. If you're a synthesizer person, same company. And HP, and then there's people that make their own. So if you're into like Arduino or into electronics or something, this is definitely a good idea for a project. There are some great websites. I'm only going to list 3: drawingbots.net, TurtleToy, which is a source of information but also will help you make SVGs. If you're not that comfortable in Houdini yet, but you still want to kind of see how this procedural drawing stuff is done, TurtleToy is a great resource. And then this one, I wish it was catchier, but this is really worth a look. This guy, Beardicus, on his GitHub, he has just a really good, informative, no-nonsense intro to a bunch of different plotter stuff. So think of it as like a gateway with a lot of different doors in it, and he kind of breaks down the different places you can go. So it's like a link dump, but it's on GitHub, I guess, for some reason. I'm not sure why. And finally, you can check out my website. I don't have a lot of my stuff up there yet, but I've been meaning to. But you can also follow me at Justin Dykhouse on Instagram. I didn't put it on the slide. I don't know why. But I do a lot of these. This one is actually one of mine. And you'll see, if you care to look in the notebooks up front, you'll sort of see how it looks to see something from the screen on the paper in front of you. And it's really gratifying, and I recommend it. And with that, I will say thank you very much for your time and attention. And does anyone have any questions? So can the line change thickness over the course of the line, essentially? With some plotters it can. The one that I have now, the Axidraw, it allows the pen to go down or to go up, but it doesn't have anything in between, so it can't like press it harder. So I would basically set it up in my file that if I wanted a line to be thicker, I would do several lines kind of all going in the same direction, and then it will draw them close enough that it will look like a thick line. I also had an idea the other day while watching the thing work that the mechanism for lifting the carriage with the pen on it, lifting it up, it just lets it drop. It has like a stepper motor with a thing, and I was like, well, why doesn't it have 2 things, and then it can push down and pull? So then it could actually push further down. So that might be a modification somebody could do if they were a little smarter than myself and with access
to a rubber band to give it more pressure.
That's true.
But then you still got to think about like this line is thicker, put the rubber band on. So.
Exactly. No, that's a good point. So you can there's a way you can use a rubber band to hold the pen further down, like with more pressure. So you could set up a layer with one thickness and have it do that, and then put the rubber band on and have it do the different thickness that way. But yeah, it would be neat to have a line thickness attribute. The question is, how do you set the bounds for the paper size? The paper size is dictated by the size of the machine, and so the machine I have will draw up to a US letter size thing. So the sketchbooks I have are larger, so I just use the sketchbook there, but I don't know exactly where it's going to fall on the paper, but the machine comes with a few handy files to get you started, and one of which draws the bounds on the paper. So you can tell it, okay, draw the bounds on the paper so I know where I can draw inside of right now. The workflow to take something from 3D in Houdini and plot it 2D on the paper, I'll just describe it briefly. Again, it's from Entagma, but I think I more or less followed it when they were describing it. I'll try to do this, and I did this at dinner, so I think I'll try and do it. I'll try and be able to do it again. So basically, take a 3D object. Imagine like Tommy's head from inside Houdini. So you got Tommy's head right here. Tommy's test geometry guy inside. It's not an actual guy. He's a guy. You take his head, and then you make a stack of grids, and then you Boolean the head with the grids, and you set the Boolean to be a seam, and so the output is actually where the two meshes intersect. So then you end up with like a sort of like a old school 3D line drawing of Tommy's head. But now you're seeing the back of his head. You're seeing through his head into the back. You don't want to do that, so you want to back face cull those basically. So the way Intagma, there's different ways to do this, but the way Intagma solved it was they take a VDB and SDF of the initial geometry, and then you cast rays to the camera from every point. And if any ray intersects the SDF, you just delete it. You delete that point. So you end up with a back-face culled version of your geometry with those lines. That's one way to do it. I actually did one like that, so I actually did a couple like that, so you can see if you want to take a look. But I was talking about this with Paul, and Paul immediately came up with a better way of doing it, which I can't wait to implement, using normals interpolated from the geometry onto the lines, and then you do like a dot product with the normals on the lines, and if they're negative, they're facing away from the camera, and so you delete them, which I think would be way faster and better. I think I explained that properly. All right, I'm getting a thumbs up. So, all right, well, thanks a lot for letting me talk to you guys about this. It's been a lot of fun.